Hey everyone, in this video we'll be continuing on the Amazon Bedrock series, and we'll actually be introducing a new feature today known as Bedrock Batch API or Batch Inference Mode. And as you can see in that little agenda right there, what we'll talk about is what exactly is the difference between online and offline inference, and what are the different Bedrock kind of hosting options that exist within both of these spaces. So we kind of visited this if you've seen my SageMaker inference series in terms of the different inference modes and picking the appropriate hosting kind of mode or feature that each of these features has available to solve your use case. So we'll just kind of revisit that concept and talk about real world examples that lie in both of these domains and how Bedrock can kind of solve that with the features it provides. Then we'll get directly into a hands-on example in terms of how you can exactly set up this feature and use batch inference mode for something like summarization, for instance. And in future videos, what we'll do is we'll expand upon this, show some more kind of real world settings, whether it's video summarization or maybe in some fun projects, kind of like YouTube summarization in terms of just passing in a video and getting a general like kind of summary of it just by simply passing in the URL. Stuff or dummy projects like that, I'll make sure to build some samples and we'll kind of walk through how we can leverage this powerful feature for those use cases. But to get started, right, let's talk about online versus offline inference. And the reason this is important is if you can understand what bucket your kind of use case falls under, or if it's kind of a combination of both, we can kind of pick the right hosting options for you, be it Bedrock or any other feature. It's just kind of important, or any other service. It's just important you can kind of classify the use case you have. For online use cases, right, you're thinking kind of stringent SLAs, and this means like low latency, high throughput kind of workloads. And this is something that you often associate with the term on demand. And this is basically right. If you can think of examples where you might have something like a chatbot, or you might have something like an assistant, real-time assistant that you're working with. Anything with an online use case, you should basically be able to invoke on demand, as I was kind of saying. And within Bedrock, what there is, as we've explored in the past, is there's the API where you could use on demand inference, where you can essentially pass in the model ID and invoke the model on demand, basically, right? You'll get an instantaneous response essentially with whatever latency or kind of like SLAs that model's taking. There's also provisioned throughput within Bedrock. And this is where you can essentially allocate compute units ahead of time to kind of avoid any cold start or scale a little better. So if you have really stringent requirements, you can essentially purchase provision throughput and associate it with your model to get even better performance. Then there's also, right, something that was introduced and we can explore later, inference optimized latency. As we know, Bedrock kind of abstracts out some of these details because it's a higher level service where we don't want to really get into all the lower level details. But essentially, the serving has been optimized if you enable this mode while you're invoking the model, essentially. And this is accessible for different models, so you should check the feature matrix in the docs for that. I'll associate that. But any online use case, right, in essence, the main thing is you want to understand you have these different modes and features available for you. So when you're invoking the model with that API call, that's not necessarily where it just stops. If you're trying to squeeze out more performance, you can go the provision throughput or inference optimized kind of latency approaches just to kind of test and get a better understanding in terms of what you're doing. And this is where tools such as LLM Perf in that load testing video that we talked about, and I'll link it below in the description, you can get a highlight or a picture of how these different inference modes or options are improving the SLAs that you're comparing or benchmarking against, right? So that's when you have an online use case where you really need to be able to invoke it on demand, and you also have stringent kind of latency and throughput requirements that need to be met. Now, for offline use cases, right, this is something that can be considered more asynchronous. I might have butchered the spelling there, but with asynchronous mode, right, or offline mode, for ML use cases like this, it can be near real time when it's asynchronous or offline, essentially, completely. So there's like a bit of a happy medium here that exists, right? In terms of, do I have an offline use case where it's just like I pass in the data and get me the output results for that data? I don't really care. Just get me the result for this data set that I passed in with all the corresponding outputs for all the inputs that were in that input data set. That's where the Bedrock Batch API, right, is really effective. because it essentially takes those use cases where you might have a input data set, and we'll notice that the batch API expects a JSON lines file essentially with your inputs, and simply it will dump an output data set to S3, which contains the model outputs and the corresponding model inputs. So this can be used in an asynchronous fashion, or sorry, a completely offline fashion, but it can also be used in an asynchronous fashion as well, because when this job starts, this is essentially a job that gets executed, unlike the on-demand mode where it's just a singular API call. This is a job that kicks off. You can use this asynchronously because you can start polling the S3 bucket, which contains your output results, to start getting um, the data points as they happen. So let's say you pass in 200 data points for inference. Let's say that a few minutes have passed and you want to start seeing the outputs for models 1 through 100. You can start polling that output S3 location to essentially get the outputs that are already existing or have already been inferred upon. So you can use this in kind of a hybrid mode where it can be completely offline, or if you build a proper architecture around it, where you're kind of polling the output location, you can also do it in a bit of an asynchronous type of mode. So that's where it's very important when you come to Bedrock or any other hosting feature to really understand what bucket does your inference fall under. And then you can take a look at the service, whether it's Amazon Bedrock, SageMaker, Vertex AI, wherever it is, right? You want to take a look and understand what are the different hosting options and map it appropriately based on your use case. So at least for the purpose of this video, right? After you get an understanding of that, if you want to go in an offline or asynchronous mode, the appropriate option within Bedrock is the Bedrock Batch API. And that's what we'll be exploring. And I already talked about it a little, but it's essentially a job that occurs where you can pick the model for the underlying batch job. In our use case, we'll use Claude 3, Haiku, I believe, in this case. You essentially give a input data location, and this is going to be an S3, and you have to structure this in the format that your model's expecting. And the general file format itself is JSON lines. But obviously for Claude versus something like Amazon Nova, the general payload shape differs, as we see even in that invoke model API call, right? Each payload is constructed differently depending on the model that you're working with. And then the output data is what we're going to be parsing after this job runs, will be dumped to S3. And to clarify here, like I was saying, right, in terms of using completely offline or asynchronous mode, if you're going the offline route, you can just wait until the job completes and then grab all the results. If you would like to see results as they're getting populated, you can asynchronously pull that S3 output location to start seeing the results as they appear. So there's that route too, if you would like to go that approach. So you have to kind of pick the right architecture for yourself there. But in this case, we'll go completely offline in our example. Now, common offline use cases, right? Let's think of some real world use cases where this might be handy, is transcription, summarizations, any kind of summarization use case, to be honest. But let's say that you have a meeting that you missed and there's a transcript of that and you'd like to get that summarized. You can use something like this. So if you missed a number of meetings in a week, you can basically run a job every week that says, hey, take all this data, give me a summary of each and every single one of these meetings. Something like that, right? Or maybe even document summarization. Lots of companies, they might have a cadence where they need certain documents summarized, whether it's legal, medical, whatever it is, maybe like on a weekly basis or a monthly basis. You can basically set up the pipeline to execute this job on that cadence essentially. Different things that I can also think of, maybe a pet project that we'll explore is, let's say you have a bunch of YouTube videos that you would like to maybe take a look at to see what's good or what's beneficial for what you're trying to learn. Maybe you can have a project where you just pass in a list of links, YouTube links, maybe like my SageMaker playlist series, for example, and maybe you just want a summary of each video to see if it's something you'd be interested in consuming, right? So there's many kind of powerful, even in the healthcare field, one more example before we conclude here. In the healthcare field, an idea or an example here is maybe you have patient doctor kind of interactions, and the doctor at the end of that wants a summary of that meeting, of that transcript or things of that sort, right? So these are all kind of real world use cases you can simulate. And maybe if you watch this video and want to build your own pet project, these are all kind of dummy examples that you could take and kind of simulate or mock with your own synthetic data, right? So these are all samples. And like I said, it's a very powerful feature, but it's even more important how you choose to use it and in the grand scheme of things, how you can fit it into your software architecture. So depending on your use case, just see where you can fit in batch for your offline use cases or asynchronous use cases that you might be working with. For the case of today, I just want to introduce you at least to the feature. So what we'll be working with is we'll generate dummy data, also using Claude Haiku, funnily enough. And what I'll do is this will be a mock conversation or something of that sort that I've asked Claude to generate. And what I'll do is I will then use the batch API to summarize each of these calls or these transcripts. So you can use this as a bit of a foundation for whatever sample you might be working with or whatever use case you might be in. So with that being said, right, now that we have a bit of an understanding in terms of what exactly we're doing here, let me hop out of this whiteboard. Let me get into the console. This is the docs, by the way, for batch inference mode. I'll attach this here down below in the description as always. But what we'll do here is we'll get directly into this example that I was talking about. Right now I'm working in my SageMaker environment, as I always do. I just have all my AWS credentials configured here. But I have a notebook spun up to work with Bedrock, configured to work with Bedrock. You can also work with this locally, whatever ID you're comfortable in as well, Cursor, VS Code, wherever it is. Just make sure you're authenticated or authorized to work with AWS and the services that we need access to. And I also have the Bedrock console pulled up here. If you come down to Bedrock in inference and assessment, you'll see there's batch inference. There's also a few of the other things that we brought up, like provision throughput and cross-region inference that we'll talk about more later. But let's take a look right here. These are the jobs that I've conducted. We'll take a deeper look at this in a second. What I want to show is the code in terms of how we executed this, and then we'll take a look at the UI as well. Note that you can also do this through the UI. You can create a job here and also just pass in the model and the data set that you're working with and run it there. But I think programmatically, especially when you're trying to work with things in production, you're going to need to understand how to execute this API call at least. So if I come here into the notebook, I'll link the Git repo down below in the description as well. You'll see there's a Bedrock batch inference introduction notebook that we're working with. And in this case, right, all I'm going to do is install Boto 3 in this environment. This is what I'm going to be using to interface with Bedrock, S3, IAM, my other AWS services, the Python SDK right here. You can also use whatever SDK you're working with in your environment, depending on your use case. If I scroll down here, you'll see my first step is I want to essentially generate a data set with a dummy transcript. So I'm also actually going to use Claude 3 Haiku, not to get it mixed up with what we're executing later with the batch job itself. I'm going to use Claude 3 Haiku to make a sample or dummy kind of customer support call transcript about resolving a billing issue. So I'm going to generate this using Claude Haiku, using that invoke model on-demand API call right there. And if you see here, here's a mock transcript that Claude generated for us. And now what I'm going to do, obviously this is a little different from the traditional kind of setup, or what this would look like in real world. I'm going to make 150 copies of this. I believe for batch, by the way, you need a minimum of 100 records for it to execute. So if you have something underneath that, I don't know if that's a soft limit or stuff, so check the service quotas for that. But at least, if I remember correctly, you need at least 100 records to execute a batch job. But here now what I'm going to do is I'm going to make 150 copies of that of this data point that I've generated here. And within this, if you see, there's a few different things that I'm doing. I'm enabling a generation config for Claude. So once again, depending on the model that you're using to execute this Bedrock batch job, you have to configure the payload in the format that that model is expecting. So for Claude Haiku, you need this Anthropic version, you need the max tokens, you need the system prompt, and then you can optionally pass in some of these other parameters if you want. For Amazon Nova and other supported models, this might look a little differently, so take a look at that in the docs page. I think you can see it here in the docs too, in terms of the prerequisites, in terms of setting up data. If you see here for Claude, it's a little different from how it might look for Amazon Nova. So just take a look at that, depending on the model that you're using. Here I then create this file, this JSON lines file, and you'll see I have 150 data points within this that I'm working with essentially. This is what we're going to run inference on. Each model output should look pretty similar because it's the same prompt that we're passing in. But obviously, once again, in a real world setting, each of these might be different. So now that I've configured that, I have my input data set. What I'm going to do is I'm simply just going to make an S3 bucket. I'm going to upload my input data and also specify the output folder for which the data should be emitted to while the job is occurring. So if you see here, I'm just using once again the Boto 3 client. I'm working with S3 in this case. I'm going to create a bucket, Each name needs to be unique here. I'm going to upload that input file that we were working with. Then I'm going to make another subfolder within that bucket for the results, and that's where my results will lie in essentially when I create this job. And we'll see all of this is mimicked and also displayed on the UI, just so you can verify and validate everything. The next part is we need to create the appropriate IAM role. With Bedrock, there's fine-grained access in terms of whichever kind of S3 bucket or data you're working with. So if you see here, I'm going to grab my account ID. Once again, just using Bodo3, I'm going to pass in the region. I'm going to use East1 in this case. And what I'm going to do is I'm going to create the policy with my bucket name. This is the resource that Bedrock needs access to, the Bedrock Batch API, to one, retrieve the data that we're working with, and then also emit and write to there, right? So that's why we enable these actions to get, put, and list into that S3 bucket that we're specifically working with, along with your account ID, which you can retrieve using this API call here. So if you run this end to end, just replace it with your bucket in your specific account, you'll be able to run this in your account as well. We run this, we create a role, Bedrock Batch Inference role, and we attach the S3 access policy to that role. And if you notice here, right, I've linked the documentation here as well for it. If you want to create a custom service role, not just for working with batch inference, if there's anything for working with like model customization, agents, or knowledge bases, which are other features we'll explore, there's some specific things that you need within your IAM roles that I'll showcase how to configure as we build out those examples. But everything also lies in this documentation right here. Now, if we go through this, once we've created our role, we basically have everything we need to create this batch job. We just configure all of this in the format that that API call is expecting. And I've linked the docs for that here too. It's going to be called a create model invocation job. Like I said, this is not a singular inference. It's a job that we're going to be executing. And if we see within here, we just have to configure a few of these necessary parameters. The input data config points towards that S3 data set, the JSON lines that we uploaded. The output data config is where our output results are going to be dumped to. We work with this Bedrock client. Note this is different from the runtime client. The Bedrock runtime client is what you can use to invoke the model itself. This Bedrock client itself is a different one where you can create jobs, you can monitor jobs, things of that sort. So these are two different things. And I believe agents for Bedrock also has its own Bodo3 client that you can work with. But here we essentially instantiate this. We specify the model ID for the batch jobs, Claude 3 Haiku. So we're going to use the same one for summarization as we did for generation, which is kind of funny, I know there. But here we create the model invocation job. We pass in the ARN for the role that we're working with, the model, Claude Haiku. We'll name the job something unique there. And then we'll pass in our input and output data locations. Then this takes approximately, I think, 6 to 8 minutes. We can basically pull the status. I grabbed this from someone else who is also working with this just to kind of simplify what's happening here. You'll see that it initializes a job. It has to validate the data format and schedule and then submit it. And then you should see it in progress for a few minutes. This data set's not too large, so it shouldn't take long. But obviously the speed of this depends on the model that you're working with, the input data set size that you have, and the exact task that you're working with. So if we see here, right, you'll see that corresponding job is also existing here if you click on this. And now what I'll do is I'll parse the output results and I'll display everything in the UI too, just so you can have an understanding. I list the model invocation jobs. I basically grab the last job that I ran, which was this. You can adjust this logic if you're specifically looking for a specific job that you might have worked with like a few days ago or something of that sort. So just filter this depending on the job name that you're essentially working with, or the job ARN, the resource identifier there. I do that. I get the S3 output path for this job, which is where it's been dumped to. And what I'm going to do then is I'm essentially going to pull down all the results from that into this results directory that I've created here. So if I go within here to this results directory, you'll see a unique identifier here. So you're going to have to adjust the file path here in terms of what we're working with. You'll see there's two files. One, there's a manifest file, which contains the job summary, including metrics such as like any inference failures, any kind of inference, how many successes did I have, what is the exact kind of summary of what I'm dealing with. And you can see we've printed this here too in terms of the input tokens and the output tokens. Remember, Bedrock also gets billed on a token basis, just like other kind of providers. So you want to take a look at this to get an understanding of your overall run. Now, if you specifically want to look at each data point, obviously it's going to be a little similar in this use case because we passed in the same input data point here. You can also parse this request summary, which gives you a per request kind of granularity. If you see here, we printed out the record ID, the unique identifier there, the sample input that was passed in, and then also the output text. So if you see here, this is a sample summary that we were working with right here in this output. You'll see here's a summary of the call transcript and a general summary that Claude Haiku kind of outputted there. And you can see that across all 150 requests if you run this end to end. And this is all displayed in the UI as well. So if you come here to batch inference and you go to jobs right here and you click on this job, you'll see that there's a input data location for what we passed, but also the corresponding output location that I was talking about essentially. So if we go here with an output results, that same folder that we emitted from, you'll see those results here and you can see those exact same metrics. So yeah, at a high level, that's mainly what I had for today. I think I wanted to introduce this feature just because in the real world, there's obviously online and offline use cases. So if you're trying to use Bedrock for your use case and it's a more of an offline or asynchronous, it's a great feature that you can experiment with. What we'll do in coming videos is we'll take this and we'll also apply it to some more projects just to kind of showcase the relevance, maybe other services like integrating it with step functions to maybe have a kind of cadence or triggered using something like Event Bridge. We'll showcase all of that in a more holistic architecture to kind of simulate a real world use case more. But yeah, I think that's mainly what I wanted to cover today. I hope this video was useful as always. And if you have any questions or feedback, please feel free to leave it in the comment section down below. And if you enjoyed the video, feel free to leave a like and subscribe. I'll be back very, very shortly with a lot more in this field. Thank you so much.